Hello everyone. This is a continuation of the last video. In this video, we'll focus on modeling and deployment. When you build a machine learning model, you have your data, you build your ML code, and then you do a hyperparameter tuning to build a machine learning model. Suppose if your end goal is to get a high accuracy model, then generally what I've seen is that people start building a complex model or try in different architecture to come up to a high accuracy. But we are missing an important part, which is your data. So I have posted an experiment. This experiment was image classification, where you have to predict a Roman character and classify that into 1, or for example, if you have a Roman character 2, you have to predict it as a 2. Now, in this experiment, what we did is that we kept the model constant while we increased the quality of the data. So on the ResNet 50 model, the baseline accuracy was 66%, and as we increase the data quality, the accuracy jumped to 82%. So I have posted the link on the detailed description below, so you can have a look. It is also very important to do an error analysis once you build your model. And error analysis really depends upon what metric you choose to optimize. So for example, if you have your target as a high accurate model, you can really have a look at all of your images in the validation set and come up with a conclusion saying that, okay, I am unable to predict my class garbage and where I have most of the errors, and I can then improve the data or improve the hyperparameter to increase the accuracy. So it's always better to focus on data and hyperparameter than to focus on code and hyperparameter. All of these things, for example, code, data, and hyperparameter, you might want to keep a track to make it reproducible. So there are different tools which can help you to do that. Something like weights and biases or TensorBoard. Both of these tools provide not just code, hyperparameter, and data tracking, but also it helps you to perform error analysis. For deployment, you have to consider a lot of things. So first one is containerization. So you need to containerize your code to make it portable and easy to deploy. You can use something like Docker. In the deployment, you might want to deploy this into Kubernetes cluster for scaling and running in parallel. When you deploy endpoint, the endpoint has two options. One is online process and one is the batch mode. So it really depends upon the business requirement for the deployment on the endpoint. On the versioning, you have Git or similar version control system which can keep track of your code. You have to do an automated testing to make sure that the model is performing as expected. Something like TensorFlow Lite macro can help you do the same. You have to create a CI/CD pipeline for a continuous integration and continuous delivery. You can use Jenkins or GitLab or any other similar CI/CD pipeline to build, test, and deploy process for a newer version, which is quick to deploy in production. The last point to note is on the management and governance. There's a tool called TensorFlow Extended, where you can manage and govern your entire MLOps pipeline. It is a central location where you can monitor version and deploy your models at a single place. We'll look at a lot of examples of TensorFlow extended code in upcoming lectures. Now, imagine a scenario where you have built your model in this data, where you have your maybe it's a daylight data where you can see your garbage very clearly. But over the period of time, say the image or the data is changing to something like this, where it's it's a night times probably, and then you are not able to see your data correctly. This we called it as a data drift or concept drift. And there's something called as a model drift as well. Will this all this becomes a part of monitoring and maintenance of the system. We'll look into these examples in more detail in upcoming lectures.